Hi, it's Mr. Zachary. Here's the solution for question 28. Here's a graph of an object's acceleration versus the amount of force that is being applied. Question A asks for the object's mass. So here is my graph. Here's the original line. And if we look at it, if you look at the slope of the line is A over F, essentially. And A over F is not what happens when you use your Newton's second law. You get sigma F over A. And so you can take the reciprocal, in other words, flip it upside down, and you get that A over sigma F is equal to 1 over the mass. So the slope of this original line turns out to be 1 over the mass. So then I look at the slope of the line and I take 2 points and I calculate that the slope is 4. And so the mass, remember, is the slope is 1 over the mass, and so the mass is 1 over the slope, and so the mass must be 1/4 of a kilogram, or 0.25 kilograms. Another way you could have solved this was to say, well, let me look at some data and let me put in data that I know. And one of the points that I know is 0.25 newtons of force gives me an acceleration of 1 meter per second every second. And so the mass to do that must be 0.25 kilograms. Now you can't do just one point. You need to see what the overall it is. And so I do another point, I get the same mass. I do another point, and I get the same mass of 0.25 kilograms. Then part B asks me for what would the line for half the mass be. Well, if we have half the mass but the same force, using Newton's second law, half the mass would give me twice the acceleration if I have the same force. You can use numbers to do that, but if I look at this, I can say, well, at this force, I had 1 meter per second squared of acceleration, so now I'd have 2 meters per second squared of acceleration. Here, I had 2 meters per second squared of acceleration, so now I need twice as much because the mass is half as much, and so the acceleration is 4 meters per second squared. Now, if the mass were 5 times bigger, and I used the same amount of force, then the acceleration would be 1/5 as much because I need it to add up to this or multiply to the same number. So here, the acceleration is 2 meters per second squared. So 1/5 of that is 0.4 meters per second squared. And here, the acceleration is 4 meters per second squared. 1/5 of that is about 0.8 meters per second squared. And so there is my line for 1/5. It would be much lower.